presenting our second partial project of mechatronics design. It consists on steel ball shooters. We are Carlos Nestor, Janet Castillo, Michael Uriel, and Alejandro Islas.
The problematic here is that a customer gave us a prototype that he was working on that shoots a steel ball with a device made of aluminum. The customer thinks that the prototypes work excellently according to his needs, but he wants to manufacture 100 of these devices for a contest. So we're going to do a redesign to make the manufacture cheaper. And the only requirement is that the coil spring is to 1000. The workflow is the next one. First, we're going to do the dynamic simulation and the stress analysis so we can work on what's wrong about the design that he's providing us, and then do a DFMA to make a new model. We're going then to do the technical drawings, and finally the render.
Before the dynamic simulation, we searched the formulas for parabolic shoot and the velocity with the spring. These are the ones that we found. And the first one is to calculate
Velocity.
the maximum distance
Oh.
achieved by the gun. The second one to search the angulus for the maximum distance, and the third one to find the velocity by the coil. The results were the next one. The initial velocity must be 3.29 meters per second. The angulus should be 42.7 to achieve a distance of 1.2 meters, considering the distance of the shoot gun, and the distance that the spring should be
30 centimeters.
30 centimeters. Okay.
With our first dynamic simulation, we noticed that the shooting was right with our calculations. It was the 1025 millimeters, which is 2.5% of error. We have here the video with the simulation.
This video shows us that the design that the customer gave us is functional. It achieves the distance that we need. So we only need to optimize the materials, the cost, and the design.
Yeah, we checked it out also the stress analysis on the spring of maximum compression and maximum elongation, and we noticed that the tape doesn't have too much stress.
It's important to notice that the safety factor is over 15, which is a lot. So in the design, we are looking to decrease that value. We apply the DFMA by following these steps.
Minimizing the number of components, the standardized components, minimize the number of fasteners, and design to facilitate the manufacturing.
The redesigned model simulation gave us a result that the shoot gun threw the ball to 1060 millimeters from the base, which is a percentage of 6 in the error. This is small, and we think it's caused because of internal forces and the distance of the cannon.
So we also have the video about our new design. Yeah, it also achieves the distance that our customer needs.
So now we know our design works, and this is what we did. First of all, the cannon is only a tube cut by half, so it's very easy to manufacture, it's cheap, and It doesn't require as much time. The base has a fixed angle of 42.7 to achieve a distance of 1 meter. We don't need to change the angle, so we decided to fix it. The base and the rest of the components remain the same.
And we have the second stress analysis in the tape of our gun, and it also have a safety factor of over 50. And in conclusion,
We didn't decrease this safety factor because the design is already cheap and works. So if we decided to decrease this, we would increase our cost, reduce the durability of the piece, and there's no need to redesign. Our values are okay, and the shoot gun actually works. So it's a good design, it's cheap, and it's easy to manufacture.
and that's all.